Hello everyone, very good evening and welcome to Prep Funda. How are you guys? This is Sanjay Rathi and today I am going to discuss what first order transient RL circuit, register inductor circuit. तो जैसा कि आपको पता है ना, ट्रांजिएंट इज वेरी इंपॉर्टेंट टॉपिक फॉर एनी कॉम्पिटिटिव एग्जाम्स, स्पेशली फॉर व्हाट गेट एंड इंजीनियरिंग सर्विसेज, HPCL एंड इसरो एंड सो ऑन गाइस. ओके, और आप देख रहे हैं नंबर ऑफ वैकेंसीज इस साल आ रही है, तो गेट एग्जाम को आप सीरियसली लीजिए. और गेट में आपको टॉप रैंक अचीव करना है तो आपको रेगुलर क्वेश्चन प्रैक्टिस करनी होगी. तो चलिए आइए कमांड करते हैं आरएल सर्किट में विद व्हाट सम इंपॉर्टेंट कॉन्सेप्चुअल numericals. So everyone please join the session now. Is it audible? Let me know that sound quality, picture quality, everything is fine. Yes please. 1 minute. Yes, I think everything is fine now. तो चलिए आते हैं जरा. दैट इज व्हाट दिस इज अ नेटवर्क नेविगेटर सीरीज, योर गाइड टू नेटवर्क कॉन्सेप्ट्स, एंड हियर network through questions guys. With questions we are getting the command. I'm trying to cover what questions from standard textbook, some previous year questions, so that it will boost your confidence. There are no irrelevant things, right? I'm not going to discuss what redundant topics or what redundant questions. Just we are discussing here relevant questions, expected numericals in coming exams, especially for what gate examination. Okay, so I think it is audible, everything is fine now. Okay, then first of all, that is my introduction. Myself Sanjay Rathi, 24 years of teaching experience, and during this 24 years I have trained more than 1 lakh students. तो अगर आप मेरे एक्सपीरियंस की बात करेंगे तो क्या बहुत ही ब्रिलियंट लड़कों ने एग्जाम निकाला है, टॉप किया है, वो 0.01% है. जो मेहनत कर रहे हैं उन्होंने इस एग्जाम में टॉप किया, एंड दैट इज माय एक्सपीरियंस, राइट? मींस व्हाट, यू हैव टू मेंटेन द कंसिस्टेंसी विद पॉजिटिव माइंडसेट. तो दैट इज माय एक्सपीरियंस, एंड आई हैव क्वालिफाइड एंड सेलेक्टेड फॉर इंजीनियरिंग सर्विसेज एग्जाम मल्टीपल टाइम्स. दीज आर माय रैंक्स इन इंजीनियरिंग सर्विसेज एग्जाम दैट इज कंडक्टेड बाय UPSC, and I have trained more than 1 lakh students for these competitive exams through offline classes and through online classes. Okay, तो चलिए आइए जरा देखते हैं और क्या क्या है आप इस सेशन में. Then that is my Telegram channel. If you want the PDF of this session, then you can join. That is Electronics by Sanjay Rathi. Just after the class, I will upload the PDF on my Telegram channel. Okay, give me 1 minute. Yes, please. Okay, now I think everything is fine now. Then this is my channel, or here you join for what PDF or what daily important questions for latest information about the exam, or if you have any doubts, then yes, you can ask your doubts here. Okay, and one you will get the idea about the running paid classes. Suppose the analog is running from morning 6 to 8, you can join that. Pin me or message me, I will send you the description about that. Okay, then that is the schedule. This week we have discussed how to cover network, KCL, KVL, Thevenins and Nortons with dependent sources, two-port network with H and ABCD parameters. Now this is the first order RL circuit. Okay, and if you want that first order RC circuit, then I am going to take session on that first order RC circuit. Stay tuned with us and subscribe the channel so that you will get the link for that. Then that is about the paid classes, analog electronics, ideal and practical diodes with numericals. You can watch this session, that is demo lectures are available. Now what is the RL or RC circuit guys? First of all, just I will give you the brief idea about the RL circuit, and then we will solve numericals. Okay, first thing, inductor does not allow sudden change of voltage, right? Inductor does not allow sudden change of voltage or current. Tell me, voltage or current? तो देखिए कैपेसिटर डज नॉट अलाउ सडन चेंज ऑफ वोल्टेज एंड इंडक्टर डज नॉट अलाउ सडन चेंज ऑफ current. Why? Because the voltage across the inductor is given by L di by dt. L di by dt. If there is a sudden change, what is the meaning of the sudden change? Then di by dt will become infinite. Sudden change, abrupt change. This is called abrupt change. In 0 time it will switch from, for example, it is 1, it is 3, and from 3 to 5 it will switch quickly. So what is the rate of change? Infinite. Then VL will become infinite. Voltage across the inductor will become infinite, and that is practically not possible. Voltage across the inductor, that is infinity, practically not possible, and that's why inductor does not allow sudden change of voltage, current, not voltage, right? Because of that. Now, if suppose you have the infinite or impulsive voltage, then it will allow. Why? Because the current across the inductor from this equation is 1 by L integral of V dt. So from 0 negative to 0 positive, if you want the sudden change, so you have to apply what? Impulsive voltage or infinite voltage. Impulsive voltage or infinite voltage. As you know, integration of from 0 negative 0 positive is del t dt is what? 1. Finite value, and that's why if you are going to apply the impulsive voltage or what? Infinite voltage, then inductor will allow sudden change of current. Otherwise, it will not allow. Then, second important thing, for DC, inductor act as short circuit. This will act as short circuit, means its impedance is what? 0. Under steady state. Under steady state. Number of students are confused with this. What is the under steady state means? What? Suppose we are giving the infinite times, then inductor will charge, and once the inductor will charge, finally at infinity it will act as what? Short circuit for DC. So DC, and that's why under steady state, that is, suppose this is the inductor and that is the circuit. This is the 10 volt, this is R, let it is a 2 ohm, and this is 2 Henry. So exactly at a t equal to 0, we are going to close this switch. We are going to close this switch exactly at t equal to 0. Means for before t less than 0, what about the switch? It is open. So for t less than 0, switch is open. Switch open. And let it is an unenergized inductor. So what is the current across the inductor? I0 negative. Just before the switching action. What is the meaning of just 0 negative? Just before the switching action, switch is open, and what is the current through the inductor? 0. And inductor does not allow sudden change of current. Inductor does not allow sudden change of current, means just after the switching action, just when we are closing the switch, again the inductor behaves what? Like open circuit, because it does not allow sudden change of current. What is the diagram at t equal to 0 plus? Diagram at t equal to 0 plus, the switch is closed and inductor will act as open circuit. What will be the current through the circuit? Suppose this is the 10 volt. Current is 0. What is the initial current through the inductor? 0. What is the initial current through the resistor? 0. And the complete voltage will come across the inductor. What is the initial voltage across the inductor? 10 volt. Because it is open circuit, so complete voltage will come across the inductor. And that is called what? Initial condition. Initial condition means initially if it is unenergized, inductor does not allow sudden change. Just before switching and just after switching, current is 0. Therefore, initially inductor acts as open circuit. Output voltage across the inductor is 10 volt. What is the voltage across the resistor? 0. What is the current through the circuit? 0. Now, when we are giving the sufficient time, inductor will charge exponentially. When the inductor will charge exponentially at t equal to infinite, at t equal to infinity, now same diagram at t equal to infinity, inductor will act as short circuit for DC. Then this is the 10 volt. This is the switch is closed, resistor and inductor will act as short circuit. Therefore, what is the infinite voltage? 0. Now, what is the current at t equal to infinity? And that is called steady state condition. So, I infinite through the inductor is given by V by R. This is R, this is V, and that will become 10 divided by 2, 5 ampere. And that is called what? Steady state current. Okay. So under steady state, capacitor will act as what? Short circuit. Inductor will act as short circuit, and therefore what is the current here? 5 ampere. It is a steady state current. What is the energy stored in the inductor? It is given by E is equal to half of Li square. So what is the value of the inductor? 2 Henry. What is the current? 5 square. These two cancel and 5 square is 25 joule. 25 joule is the energy stored in the inductor at steady state, means at t equal to infinite. Okay, so we are getting this. Now watch this. I think up to this point, sound quality, picture quality, everything is fine. Give me 1 minute. Yes, please. Now, at t equal to infinite, that is the 25 joule under steady state, that is the situation. Now, what we can do here after that, exactly at t equal to 0, what was the current through the inductor? 0. At t equal to infinity, what is the current? V by R, right? V by R means 10 by 2, that is the 5 ampere. So from 0 to what? V by R, what is the curve? That is called what? Time response. So here, this is the time, and final value is V by R through the inductor. That is nothing but 5 here, 5 ampere. And initial value is 0, so this is 0. So it will charge exponentially. It will charge exponentially. So this is on the time response. So how we can get? You have to remember this general formula. IT is equal to what? I final minus I final. I final means at infinity. I initial e raised to power minus t by tau. E raised to power minus t by tau. What is the tau? Time constant for inductor circuit? L by R. So what is the L here? 2 Henry. What is the R here? 5. Watch this. No, sorry. 2 and 2. Okay, 2 and 2. 2 Henry and 2 ohm. So 1 second will become the time constant. 1 second is the time constant. What is the final value? V by R. So general formula is V by R. What is the final value? V by R. What is the initial value? 0. E raised to power minus t, because tau is 1. That equation will become V by R 1 minus e raised to power minus t. And that is the formula, where time constant is L by R. Now, what is the value of the V by R? That is what? 5. Okay. Now, in the one time constant, that is the tau, it will reach up to what? This value. 0.632 of the final value. V by R. How we can get? T equal to 1 second, that is the time constant. Put T equal to 1 second, and V is equal to what? 10 volt, R is equal to 2 volt. 1 minus e raised to power minus 1, because 1 second is the time constant. When we are finding 1 minus e raised to power minus 1, everyone use your calculator. Suppose you are going to find e raised to power minus 1. Then again minus 1, then you will get 0.632. 0.632 of V by R. 63.2% of V by R. So you can multiply with the 5 and you will get exactly what is the value, 3.16. 3.16. In one time constant, it will charge up to this value. And it will take around what? 4 time constant to charge up to 98% and 5 time constant to charge up to more than 99%. So we can't wait up to what, infinity. That's why after 4 time constant, just we are saying that it will charge up to what, 98%, and transient is over and circuit reached to what, steady state. This is the tau and this is what, 4 tau. 4 time constant, or in 4 time constant it will charge up to 98% of the final value. You can put here 4 e raised to power minus 4, you will get the answer, 98%. Okay. So what is the inductor? Inductor initial current is 0. It will charge exponentially, and guys then V by R, and that is the equation, and that is that in time constant L by R, and it will charge up like this. So ये है basic idea. Are you ready to solve some questions, guys? So this is the, I have given the very basic idea about the RL circuit. RL circuit with the source. RL circuits with the DC source. So always remember, initially it will act as open circuit if initial current is 0. Finally it will act as short circuit for DC source, and from initial to final it will charge exponentially like this. After 4 time constant, transient is over, steady state will reach, and that is called transient portion. And after that is called steady state. Steady state, and that is the general equation you can use to find the current in terms of what time. तो ये आपको इक्वेशन यूज करना, I final minus I initial e raised to power minus t by tau. ओके, तो चलिए देखते हैं जरा न्यूमेरिकल. ये मैंने पूछा था on my telegram channel. I have uploaded this question. So how many students you have given the answer for this? Just I will watch. New students, please try to give me the answer for this. What is the answer for this question? What is the answer for this question? Okay. Now, that is what, how to solve this question. The values of V is not given. That would result in a steady state current of 1 ampere through the inductor in below circuit is. Steady state current of what? 1 ampere. Switch is closed at t equal to 0. Then steady state current of 1 ampere. This is the DC source. Therefore, under steady state, the inductor will act as what? Short circuit. So you can make it what? Short circuit. You can make it what? Short circuit. So under steady state, you can make it what? Short circuit. Then let this is short circuit. At t equal to infinite, this will act as short circuit. When inductor will act as short circuit and the switch is closed. Now guys, what is the current here? 1 ampere. Now, if this current is 1 ampere, then this 10 ohm and this 10 ohm are in parallel because the values are same. Definitely this is also 1 ampere. This is 1 ampere, this is 1 ampere. So what is the current here? 2 ampere. And guys, what is the voltage at this point? This is the 1 into 10. What is the voltage at this point? 10 volt. Now, can you apply the KVL? Yes. V is equal to, drop across this 10 into 2 plus 10, and that is nothing but 30 volt. So, under steady state, that inductor will act as short circuit. This is 1 ampere, both are equal. That's why this is also 1 ampere because they are connected in parallel. And 2 ampere current, 2 into 20, here it is a 20 volt, here it is a 10 volt. That's why total voltage is 30 volt. Finished. So answer for this question is what? 30. Answer for this question is what? 30. Now, then this type of questions, very easy question, what is the position of the inductor and so on. But sometimes we are getting some good questions on that. Dekho, the switch in the circuit shown is in open position for long time. It is closed at time t equal to 0. T equal to 0, it is closed. For ILT, for the time t greater than 0. So in this diagram, open position for long time. It is open for long time. If it is open for long time means what? This is unenergized because the extra energy will discharge through the 8 ohm, and therefore what is the energy across the inductor? 0. Means when the switch is closed, what is the initial energy across the inductor? 0. And that's why just before the switching and out current is 0, and after the switching current is also 0 because inductor does not allow sudden change of current. Exactly at t equal to 0, we are just closing the switch. So what is the formula for that? How we are going to solve this question? Watch this. Now this is the first order circuit because it is a simple RL circuit. So always you can use this equation. IT is equal to I final minus I initial e raised to power minus t by tau. Now here we are having the resistor. So what is the tau here? L by RTH. Just I will give you the idea how to find the RTH. Exactly at t equal to 0, the switch is closed. Now, first of all, what is the initial current? Already we have find 0. Initial current is 0. What is the final current? Finally, inductor act as what? Short circuit. When finally inductor acts short circuit, to complete current, this will short circuit the 8 ohm resistor. This is the 2 ohm and this is the 24 volt. This is short circuited to 24 by 2, 12 ampere will flow like this. 12 ampere. So what is the final current? 12 ampere. What is the initial current? This is not 24 by 2, 12 ampere. What is the initial current? 0. Now we have the final current, we have the initial current. What is the time constant? Time constant is L by RTH. What is the meaning of this? What is the value of the L? 0.8. Now make it what? Open circuit. Make it open circuit. And then find the Thevenins across this. Thevenins across this. What is the Thevenins resistance seen at this point? First of all, remove the inductor and what is the Thevenins? To find the Thevenins which is closed, make it 0. Make the battery 0. When we are making the battery 0, so what is the RTH looking from this point? 8 and 2 are in parallel. 8 parallel with 2, that will become 8 into 2 divided by 8 plus 2, 16 by 10. This is the RTH. So what is the time constant? What is the L here? 0.8. And what is this? 1.6. So time constant will become L by RTH. 0.8 divided by 1.6, that is nothing but 1 by 2 second. 1 by 2 second. Now we have the initial value, final value, time constant. Therefore, what is the equation here? IT will become, what is the final value? Already I have find. This is the 12 ampere. 24 by 2, 12 ampere. 12. What is the initial? 0. E raised to power minus t by tau, 1 by 2. It will become 12. 1 minus e raised to power minus 2t. This equation is valid for t greater than or equal to what? 0. That is called what? Current through inductor. है क्या कोई option? Yes. 12 into 1 minus e raised to power minus 2t. That is the answer. C is the option. So what I have done, very simple. I have just find the initial current, just find the final current, and what the time constant of the circuit, guys. Time constant of the circuit. Or in this way you can solve the question on inductor. So normally we are getting good questions for electrical students. For electronics student we are getting good questions from what? RC circuit. So after that I will solve some RC circuit questions. Okay, so before that try to solve this question. ये भी अच्छा क्वेश्चन है. अच्छा, आप लोग अभी रेगुलर सेशन, आर यू कंफर्टेबल विद हिंदी और व्हाट इंग्लिश और व्हाट इंग्लिश, हिंदी प्लस इंग्लिश? तो कैसे आप लोग चाहते हैं ये सजेस्ट कीजिएगा. एंड ऑन टेलीग्राम चैनल यू कैन पिन मी, सजेस्ट मी ऑन विच टॉपिक यू वांट सेशन. डोंट वेट फॉर व्हाट लास्ट डेट एंड सो ऑन. जब गेट का फॉर्म भर जाएगा तब तैयारी स्टार्ट करेंगे. सितंबर के बाद तो स्टूडेंट्स स्टार्ट करते हैं. तो टेक इट व्हाट सीरियसली एंड स्टार्ट योर प्रिपरेशन एज अर्ली एज पॉसिबल. Now tell me, find the time constant of the circuit. Let I0 is 5 ampere. I0 is 5 ampere means what? Initial current is 5 ampere. If the equation of the current is required, then initial current is required. As well as if you want to find what is the initial energy stored across the inductor, then half of Li square, that is the 0. Now, what is the time constant of this circuit? Time constant of this circuit is given by L. L is here by RTH. RTH means, suppose here inductor is connected, like this is the A, this is the B. So first of all you have to remove the inductor and you have to find the RTH across this. And but what is the problem here? We are having the dependent sources. Here we are having the dependent sources like 2 Vx. This is the 1 ohm, this is the 4 ohm. So how we can solve this question, dependent sources? So already I have taken session on what? Thevenin's and Norton's theorem with dependent sources. So my dear friend, in transient again we have to use the concept of Thevenin's and Norton's. तो Thevenin's and Norton's का concept use करना है. Then L by RTH. Okay. So what is the method here? First of all, remove the RTH. Remove the RTH. Then I will give you each and everything about that, time constant and how to find the equations and so on. Remove the inductor because we want the RTH across this. Now watch this. But this current is not 0, remember. And that is what this is the Vx or on Vx, this is dependent. Now what is the method here? You can connect a battery of 1 volt. That is the method here. And let that battery will give the current capital I. So what is the RTH will become? RTH will become 1 upon I. That is the method already I have mentioned in Thevenin's. So link will be given in the description. Please go through that. 1 by I, or otherwise I will make a pin. Please go through that. So 1 by I we have to find. Now this is the Vx will become 4 times of I. 4 times of I, and that is become 8 times of I. 8 times of I. Okay. Then तो कैसे सॉल्व करेंगे बताओ जरा. How we can solve this question? How we can solve this question? Think about it. Easy से easy. We have to find the 1 by I only. We have to find the 1 by I here. बोलिए जरा. देखो मैं आपको एकदम इजी बोलूं तो मैं ले लूंगा. If I have number of options, but suppose this is the I2 current and this is the I1 current. I1 is nothing but I. I1 is nothing but I. And first of all, I will write a KVL in this loop. So it will become 1 into I2 minus I1. I2 minus I1. And what is the I1? I1. This is plus. This is minus. 1 into I2 minus I1. So in upward direction I2 minus I1, then it will become 4I2. Then it will become minus 2Vx. So what is the Vx? 8I minus, because when we are moving in this direction, this is the minus 8I is equal to what? 0. So it will become I2 minus I plus 4I2 minus 8I is equal to 0. So 8 plus 1 9, and this will become 5i2 is equal to 9i. So what is the I2 is equal to 9 by 5i. Check my calculation. That is the 9 by 5i. We have to find a 1 by I. Now write down the KVL in this loop. When I am writing the KVL in this loop, or you can follow this loop, both are correct because now we have the value of, so here you can write -1, that will become 4 times of I, and that will become 4 times of I2 is equal to 0. So what is the I2? 9 by 5i. 9 by 5, 9 into 4, 36 by 5i is equal to 1. So here it will become, watch this, 5 into 4, 20 plus 36, 56 by 5i is equal to 1. So what is the 1 by I? 56 by 5. Check my calculation. So 1 by I will become 56 by 5 ohm. 56 by 5 ohm. That is the value of what? RTH. That is the value of RTH. So what we are doing, just we are writing the KVL. I am just writing. That is here I have assumed the mesh analysis. Already I have taken the session on mesh and super mesh analysis. So that will become I2 minus I1 into 1. I1 is what? Nothing but I. 4I2. And that is the minus 2x. What is the Vx is equal to 4i. That's why this is 8i. So minus 8i, right, is equal to 0. Then try to solve that equation. I2 minus I, 4i2 minus 8i. Okay. Then 5i2 is equal to 9i. I2 is equal to 9 by 5. Then write down the KVL here. Minus 1. This will become 4i. This will become 1 minute. I think something is no, okay, no, okay. I have written the mess here. You can write here, no problem. Just this one. In KVL for just for a closed loop, I have written -1, 4i plus 4 times of I2, and then I2 is replaced by 9 by 5i. I2 is replaced by what? 9 by 5. 9 into 4, that is the 36 by 5. 56 by 5. So what is the 1 by I? 56 by 5. So what is the time constant of the circuit? L by RTH. L by RTH. What is the L here? 2 Henry into 1 by RTH. So RTH will become, RTH is what? 56 by 5. So it will become 5 by 56. 5 by 56. So that is the 10 by 56, or you can find. Okay. So this is the value 5 by 28. तो ये कैलकुलेशन चेक कर लीजिएगा. बाकी देखो मेथड यही है, मेथड ये आएगा आंसर, और इन दिस वे यू कैन सॉल्व दिस क्वेश्चन गाइज. Okay, so these are the questions on what? Inductor. Now that is time for some assignments. So guys, try to solve this type of questions. Some questions from previous year question paper, some questions from what? Standard textbook. So that is the assignment for you. In next class I will give the answer for this question. Try to solve this one. Then we will in coming session we will solve some questions on what? Initial conditions like this. Okay, in the circuit of the figure, the value of dVR by dt and dVL by dt are respectively. This is a very important circuit. That is the question on second order circuit. Next week I am going to start what? Second order. So simple thing, stay tuned with us, subscribe the channel so that you will get the notification for that. And initial condition, first order circuit, second order circuit with initial condition. Initial condition means what? I, di by dt, d square I by dt square at a 0, at a t equal to 0 plus. This is called initial condition. Or what, v dv by dt, or what, d square v by dt square at a t equal to 0 plus. These are called initial conditions. So try to solve. This is the second assignment. Next week I will take session on that, initial condition from second order, then I will solve this. This is an inductor and capacitor, and that's why it is a second order circuit. So guys, this is the screenshot you can take and follow all this session, because in Thevenin's dependent sources already I have solved. So we have used that concept here in RL circuit, right? And I have used what, mesh analysis. So already I have discussed KCL, KVL, mesh, nodal analysis, and first session how to cover the network. And before that you can watch what, 50 plus 30 plus 10 plus 5 formula. This is also important, how to cover the syllabus, 100% syllabus, and then syllabus of what, network. That is a very, very important session for you guys. Okay, so this is my channel where I will upload the PDF. To join that channel and try to attempt all the quizzes, try to solve all the questions on my Telegram channel. After that I will upload the PDF, go through it and try to solve that question. Okay, then finally, thank you for attending the session. Thank you very much. Like the session, share the link of this session and subscribe our channel guys. Thank you.